Okay, 7th grade. Here we go. This is it. Last lesson of this school year. This is a long one, so break it up into chunks if you can't stand to watch it all at once. But I wanted to post everything early in the week because absolutely every single thing that you have due or overdue is due by Friday, May 22nd, okay? This is actually probably the best math I'm doing right now. So experimental probability, it's kind of fun. I have a pencil, I've got my calculator. I do have a highlighter, might highlight a couple things, okay? I'm gonna keep going through this. If you get tired, pause it, take a break, come back, finish it up, okay? We're gonna do experimental probability. Okay. All right, Jada has a bag with tiles in it. She pulls a tile from the bag without looking. She records the shape and then she puts the tile back in the bag. She ends up with 5 stars. She pulls a circle 3 times and a square 2 times. Suppose Jada does the same experiment 100 times. What is a reasonable prediction for the number of times she will pull a star, a circle, or a square? Okay. So this is called experimental probability. It's what could happen if you pulled these out of a bag. It's not what should happen, it's what could happen. Okay. Okay, so let's just read these questions. How many times did Jada pull a tile from the bag? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She pulled it 10 times. How many tiles did she pull that has a star on them? She pulled out 5. Write a fraction to represent, write the fraction of tiles that are stars. So she pulled 5 out of the 10 were stars, right? Half of them were stars, 5 out of 10. Okay. Write a fraction to represent the tile that are circles. So how many circles? She pulled 3 out of 10 circles. So that's half. That's like 50%, right? If I made it right, do you remember how we did our percents, or anything over 5 out of 10 would be 50 over 100. So this would be about 50%, about 30%. Write a fraction to represent the tiles that are squares. So that's 2 out of 10, which is about 20 over 100, which would be about 20%. Okay, this would be about 30%, right? 30 over 100. All right, you guys remember that. Okay, if Jada pulls, and so I started answering some of these questions. If Jada pulls 100 tiles out of the bag, would you expect there to be more tiles with stars or more tiles with squares? Oh, come on. Sorry, I got a barking dog at the door. Which one did she pull more of, stars or squares? Right, she pulled more stars. So I would predict that she would pull more stars because she pulled more stars up here. Okay. Okay, let's say Jada pulls 100 tiles out of the bag. What could you predict for how many tiles she would expect to be stars, circles, and squares? We already did this. Okay, so what did we say about stars? Stars were first. If she pulled 5 out of 10, that's equal to 50 out of 100, right? Times 10 times 10. And then what's the next one? Stars, circles. So she pulled 3 out of 10 were circles. So that would be 30 out of 100. And then squares, she pulled 2 out of 10, which would be about 20 out of 100. And these are just equal fractions, really, honestly. Okay. This is a lot of reading, but it's not that difficult. Okay. When you find the likelihood that an event will occur, you're finding the probability of that event. Each time Jada pulls a towel from the bag, she's conducting an experiment. In probability, okay, here's a couple definitions. The experiment is the trial. Okay, like your science fair stuff. Every time you try an experiment, that's a trial. The result of the trial is the outcome. So you're going to do it, and then you're going to get an outcome. Okay? Jada pulled a tile out of the bag 10 times. She completed 10 trials. The outcome of each trial was either a star, a circle, a square. So 10 trials, what were the outcomes? These were the 3 possible outcomes. You can also use the notation P parenthesis outcome to represent the probability of getting an outcome. For example, P star, so this is the probability, what do I want to highlight? The probability of getting an outcome looks like this. So you might do the probability of getting a star. I like writing them like that. So what's the probability of a star? Well, the probability of the star, you can find the experimental probability by pulling each shape from the bag based on the outcome. So experimental probability is based on somebody's trials. Okay, just highlight the whole thing. It's not what should happen, it's what could happen. All right, so that's different. If it's what should happen, like if I have a coin and I flip it, it should be 50-50, right? 50 heads, 50 tails. But you and I both know I could flip that coin and there's no way they'd be half heads or tails. They might, but probably not. So that's called experimental probability. Okay, so we took the number of stars over the number of trials, right? 5 out of 10. Number of circles over the number of trials, 3 out of 10. And for the square, 2 out of 10. Each probability is based on the result of Jada's experiment. If Jada repeated the experiment, she would likely pull more stars than circles or squares. She might get a different number of stars and circles and squares, but over a large number of trials, you would expect the ratio of the samples to reflect the ratios in the population. You can use proportional relationships, so equal fractions, to predict the number of stars, circles, and squares if Jada pulls 100 tiles from the bag. And I already did this with you, so I jumped the gun, but that's okay. Can you see it? I went from 5 over 10 is equal to what out of 100? So we just multiplied by 10. So 5 over 10 is 50 over 100. 3 over 10, multiplying both by 10, is 30 over 100. And 2 over 10, multiplying both by 10, is 20 out of 100. So based on the initial experiment, if she does this experiment 100 times, she should pull about 50 stars, 30 circles, and 20 squares. Now, let's say Jada repeats the experiment 100 times. Do you think her results will match her predictions? What do you guys think? Will these be exactly like that? No, you know they're not going to. I'm going to say probably not. This is why people like gamble and play the lottery. You know what should happen, but man, is there that chance that you might win? What are the chances of you winning the lottery? Like super low. But could it happen? Sure, it could happen. Could this happen? It might, but probably not. Okay? All right. That's why people get, oh, here. FYI. As far as the homework goes, I know you're not going to do it, but would you just at least flip open your practice and problem solving book and look at page 329 and 330. You know, the last questions on that page are kind of tricky, but do a couple. I'm going to post all the answers. I'm not saying you have to do them all, but just take a peek, okay? I'm going to keep going. If you're tired, take a break. If not, I'm going to keep moving. Okay, next page. I'm on page 292. Finding experimental probabilities. Okay, let's see. Luke rolls a number cube and records the results in a frequency table. So I have, let me find it here. Ta-da! His are numbered. You know the ones I have at school that have the numbers on them, but we'll pretend. So that's a cube. Mine has 2 dots instead of the number 2, but mine has all of those numbers. Okay. Here's what he did. So he rolled a 1 once. He rolled a 2 once. He rolled a 3 4 times. He rolled a 4 no times. He rolled a 5 twice and a 6 twice. Okay. Based on the results, what is the probability of rolling a 1, 2, 3, 4, 5, or a 6? Okay. Let's see what happens. First, they said you could make a line plot. And sure, you could make a line plot. I don't know that you need a line plot, but by all means, make a line plot. These are the possible outcomes. 1, 2, 3, 4, 5, and 6. And these are the trials. These are the experiments. Rolled 1, 1, 1, 2, 1, 2, 3, 4. Rolled a 3 4 times. Didn't roll any 4s, so there's nothing there. Rolled a 5 twice. Rolled a 6 twice. Okay? Now, here is the probability of rolling a 1. Okay, the number of 1s that he rolled over the total number of rolls. The number of 2s that he rolled over the total number of rolls. Okay, so I need the total number of rolls. So let's go back up here and see how many times he rolled this thing. So I'm just going to kind of add them as I go. 1, 2, plus 4, 6, none, 7, 8, 9, 10. So he rolled 10 times. We need to know that total. That's important. Next page. Okay. Look at the chart on the previous page. Yeah, how many times did he roll the number cube? 10. Based on Luke's experiment, find the probabilities of rolling each number. Okay, what's the probability of getting a 1? 1. It's going to be 1 out of 10 times. Okay, or you could say it's 10 out of 100, or you could say he's got a 10% chance of rolling a 1. Okay, go back and look at 2. 2 is the same. It's 1 out of 10, which is also equal to 10 out of 100, which is also 10%, right? Whatever that number is, over 100 is the percent. What's the probability of rolling a 3? He did that 4 times. 4 out of 10. So that's going to be 40 over 100, which is also about 40%. Oh, so that's much higher. What's the probability of rolling a 4? You got it. No chance. Now, and you and I both know that there is a 4 on a number cube. But in this experiment, he didn't roll any. If this is experimental probability. If it was theoretical probability, then he would have a 1 in 6 chance, right? Okay. Probability of rolling a 5. He rolled 2 of them out of 10. So multiply both by 10. That gives you 20 out of 100. So that's about a 20% chance. And the same for number 6. He rolled a 2. So that's about 20 out of 100, which is about 20%. Okay. Use a number cube. Okay, so I'm going to try and do this really quick. You can pause me and go get your own number cube and your own die and do this, okay? Use a number cube to perform Luke's experiment. So I need to roll it 10 times. Record your results in the frequency table on the right. Write the probability of rolling each one. Okay, so I'm just going to roll it in front of you. There's a 2. So there's 1. 2 times. 3 times. 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. Come on, give me a 6. Ah, I did get one. Okay, so I rolled every number once. Okay, how many rolls? So I'm assuming they want me to take 10 rolls. How did they fill it out on the other page? Okay, number of rolls. Okay, so I rolled this one twice, this one once, 3 times, 2 times, 1 time. I rolled it, 10 times together? So what's the probability of me getting a 1? Well, 2 out of 10, which is 20 out of 100, which is about a 20% chance. Roll a 1 out of 10, which is 10 out of 100, which is about 10%. Again, 1 out of 10, about 10 out of 100. So I got about a 10% chance of rolling a 1 or a 2. Okay. Rolling a 4, I did it 3 times. So 3 out of 10, which is about 30 over 100, which is about 30% chance. Then I roll a 5. Well, that's 2 out of 10, so that's 20 out of 100. That's about a 20% chance. And then rolling a 6 was about a 1 out of 10. So 10%. Now, what if I added all my percents up? What should they equal? Well, let's see if it works. 20, 30, 40, 50, 60, 70, 80, 90, 100. Yeah. So, oops, sorry. They should be about 100%. Okay, compare the probabilities from Luke's experiment and the results. Are your results different from Luke? Well, let's look. His probability of getting 1 was 10%. Different. Probability of getting 2, same. Oh, here, let's see. This one was different. This one's the same. Probability of getting a 3. Oh, that's different. Probability of getting a 4, definitely different. Probability of getting a 20, that's the same. Probability of getting a 6, that's different. So, what? 1, 2, 3, 4 were different, 2 were the same. So, are my results the same? No. Why? There was no way. There's no way to roll the same thing as okay, I shouldn't say no way. There is a tiny chance of rolling the same as Luke. Again, is it possible? Sure. Is it likely? No. And if this were the casino game, right, you have to match his probabilities. Could it happen? Yeah. And somebody might play that game and win big money. But usually, you're not going to win. Okay, let's try it. Use what you learned to solve this problem. Show your work on a separate sheet of paper. Okay, so we have a spinner, like a spinner, and you spin the thing, and it looks like it can land on the letter A, B, C, D, or E. Okay, it's 5 equal size sections. That's good to know. Lettered A to E. Kyle spins the pointer 25 times. I'm going to circle that, box that in. He records his result on the frequency table. Okay, based on the results, what is the probability the pointer will land on the letter D? Well, that's easy. How many times did it land on D? 4 out of 25. Okay, oh, could I make this equal to 100? Sure I can. 25 times what is 100? Times 4. Let's just do equal fractions. What's 4 times 4? So he's got about a 16% chance of rolling the letter D. 4 out of 25. What's the probability that we'll land on a vowel? Well, vowels are what? A, E, I, O, U. We got 2. We got 2 vowels. So just add them. So 6 plus 3, so 9. So he's got about a 9 out of 25 chance of hitting a vowel. So can I make it out of 100? Sure. Times 4, times 4. So he's got a 36% chance of hitting a vowel. All right, not bad. Again, if you want to look at some homework, I'm not going to require you to do it. You haven't been doing it anyways. I know you guys. But at least look over it. This is 331 to 332. Kind of peek over it. Practice a few. You know the last ones are always the hardest ones. You have to do those. I'm pushing through. We're at 15 minutes. We're cooking with gas. Okay. Now I'm on page 294. It's my last two. 294 and 295. Not my last video, but my last two in this video. Okay, I'm going to move my die. Okay. Making predictions. All right. Students in Luke's class combine the results of their experiments rolling a number cube. The results are shown on the table at the right. So Luke did it, like other kids did it, and they put all their numbers together. Okay. If the class repeats the experiment for a total of 1,000 trials, predict how many times each number will occur. Okay, well, we can do this. All right. So when all the kids combined, how many times did somebody roll a number 1? A number 1 was rolled 32 times. Well, these are all in the 30s. It's pretty close, actually. A number 6 was rolled 35 times. Can you see? This is the number cube. They all have an equal chance of being selected. The more times you roll it, the closer these numbers should get to each other, right? Because they all have an equal chance. All right, well, I'm going to tell you right now, first thing I need to know is how many times numbers were rolled. So if I add these up, where am I at? 30, 60, 90, 120, 150, 180. I can add them up, or I can not cheat, but I can use my resources and go to the bottom of the page. Right here, 200 times. 200 rolls. Okay. That's 200 trials, right? I should say trials. 200 trials. Okay. Knock yourself out. I am not going to make one of those, nor am I going to ask you to make one of those. It's a line plot. It's just turned on the vertical. That's crazy. But notice the lines are almost the same length. The more you would do this, like if you did this 10,000 times, these lines would probably start to look exactly, they'd all be the same length. Okay. Now we're going to find the probability, okay? Instead of our denominator being like a 10 or a 50, it's a 200, but I can still do this, right? So the number of rolling a 1, so if you go back up and look, there were 32 out of 200. So 32 out of 200, rolling a 2 was 33 out of 200, rolling a 3, 34 out of 200, and so on, okay? Next page. Use Luke's class data to write and solve a proportion to predict the number of results of ones rolled in 1,000 rolls. Okay, well, let's go back. How many ones did they roll? They rolled 32 out of 200. Do you agree with that? From the data on the other page, right? Now, my question to you is, can I just make an equal fraction? I think so. What would you multiply by? 200 times what is 1,000? Or you could do 1,000 divided by 200 to figure out what that number is. What is it? It's 5. So just multiply both numbers by 5. Okay, Okay. 32 times 5 is 96. $32 times 5. Nope, that's not 30. I was going to say something's not right. That's not high enough. I had fat fingers. 32 times 5. Hey, 160. Okay, so if he rolled 1,000 times, we're predicting based on their data, he would roll 160 ones. So he'd roll about 160. He'd get one about 160 times. Okay. Describe the method we used to solve the proportion. What did we do? We just made equal fractions. We used equal fractions. That's all we did. Okay. Easy enough. All right. Use the results from Luke's class to write and solve proportions and predict the results for 1,000 trials. Okay. So we just did it for the number 1. Now we're going to do the rest. Okay. Not hard. So for number 2s, I'm using my notes here. It was 33 out of 200. Now I want to know what it is out of 1,000. So all I do is multiply both numbers by 5. Times 5 times 5. So what's 33 times 5? Right? 33? Yep. 33 times 5. I won't fat finger it this time. Okay, about 165 times. Well, I don't think an equal sign is what I want. Let's do like a comma here. I'm going to use the word about, right? About 165. Okay? How about the 3s? Well, 3s are 34 out of 200. So I'm going to make that equal to 1,000. So I'm going to multiply by 5 times 5. So what's 34 times 5? So this is going to be about 170 times. How about the 4s? 32 out of 200. 32 out of 200 equal to something over 1,000. So multiply by 5 times 5. 32 times 5 is about 160. So comma, about 160 times. Okay, number 5 is going to be 34 out of 200. So times 5 times 5, 34 times 5. I have about 170. So if he rolls it 1,000 times, he'll get a 5 about 170 times. Will he absolutely get it that many times? No, but will it be close? Yeah, maybe. Okay, so 6 is 35. 35 out of 200 equal to something over 1,000. Times 5 times 5. I already did 35 times 5. No, I didn't. I thought I did. Okay, 35 times 5, 175. So he will get a 6 about 175 times. Okay. The class reports the experiment with a total of, the class repeats the experiment with a total of only 25 trials. Predict how many times the number 4 will be rolled. Explain how you found your answer. Okay, well, let's go back. So we're looking at the number 4. So go back to the number 4. The number 4 was 32 out of 200. Instead of making a number, an equivalent fraction that's larger, we're going to make an equivalent fraction that has a smaller denominator. So when my numbers get smaller, I'm not multiplying. What am I doing? I'm dividing. So 200 divided by what? Will get me 25. Well, there's 4 25s and 100. And this is 200. So I'm going to divide by 8, right? You can double check on your calculator. 200 divided by 8. And yes, indeed, it is 25. So let's divide both numbers by 8. You can do that one in your head, can't you? 32 divided by 8 should be 4. It is. So we did equivalent fractions. We just reduced. We made them, a smaller denominator. So this would be about 4 times. He would roll a 4 about 4 times. Okay. Let's do the try it out. Okay. It says use a separate sheet of paper. I don't think you need it. Another class rolled a number cube 100 times. The results of the experiment are shown. So this is so if I add these up, they should equal 100. So right, 100 trials. Okay. if the class repeats the experiment for a total of 100 trials, predict how many times the number 4 will occur. All right, well, let's go with what we know. Right now, they rolled a 4 20 times. So 4 was 20 out of 100. Oh, this is easy. Now I just want to go up to 1,000. So 100 times what is 1,000? Times 10. So I'm making equivalent fractions. So 20 times 10 is 200. So about 200 times. Okay. All right. Predict how many times an odd number will occur. So odd numbers, right? Not evens are 2, 4, 6, 8. So the odds would be 1, 3, and 5. So we add them together. So let me use my calculator. So we had 15 ones plus 17 threes, plus 15 fives. So I have 47 out of 100 odd numbers. But now I want to know what I'll get out of 1,000. So times 10 times 10. So 470 of the numbers will be odd. Oh, 10,000. My bad. I need an extra 0. I thought it was 1,000. This is 10,000 trials. Okay, so just add put another 0 on there. So about 4,700 of those numbers will be odd. Okay, again, if you're interested in the homework, I'm not going to harass. I'm not there to give you grief. It's page 333 and 334. I posted all the answers. You can at least flip through them and see what they look like. Okay, the other video that I'm going to post is going to be the guided and independent practice, and then I'll post a video for the quiz. Okay, my friends, have a good one. See ya.